This playlist deals with some aspects of Eurocode 2 version 2023. Watch this channel or this playlist for further selected topics. This video deals with clause 6, and it's about durability and concrete cover. The requirements for the concrete to withstand the environmental actions are given in EN206 with the correction of 2021. And the requirements, you can have two different concepts. The first one is in terms of limiting values for concrete composition and established concrete properties. This means that you are defining the content of a mixture, for instance. You can today we are in the version of Eurocode 2004. Then we have Annex F in the EN206, which is a table with, for instance, minimum cement content for a certain type of concrete mix. So you are really defining the content of the mixture, not the performance of the mixture. In Eurocode 2 2023, there is an Annex P, which is also allowing you to use this method of defining content of mixture. So this is the first concept, is as we do now in Eurocode 2 version 2004. A second method is that the requirements may be derived from performance-related methods. It's completely different from philosophy. So you are now defining the performance of the concrete and not the content. So the requirements related to exposure classes may be established by using performance-related methods for durability and may be specified in terms of performance-related parameters, for instance, scaling of concrete in a freeze-thaw test. And then there is a sentence following, directly cited from the code. The application of a performance-based method depends on the provisions valid in the place of use of the concrete. This is a sentence I do not understand the meaning. What does it really mean, this sentence? And what can you do with it? The Eurocode 2 2023 promotes the performance-related method and the defining of performance of concrete. Exposure classes, those are the same as we have seen in the version of 2004. All those exposure classes are the same, but they have added now the mechanical abrasion class, XM1 and 2 and M3, which was missing in the previous code. So that's fine. There's a new concept, and they call it the exposure resistance class. And the exposure resistance class is needed to define the performance of the concrete. Classes for defining the resistance of concrete against corrosion induced by carbonation, it's then XRC, exposure resistance class for carbonation, or for chlorides, it's XRDS, and damage caused by freeze and thaw attack is XRF. Now we will look at the XRC classes. They are presented with the resistance class designation given the 90% correctile for the carbonation rate after 50 years of exposure under the XRC reference conditions. Okay, so it's a statistical approach. As a rule of the thumb, you can, for instance, say the XRC class number, we will just look into that just now, has a dimension of carbonation rate. So, for instance, XRC class 4, XRC 4 means that the the number 4 is in fact millimeters per square root out of the years. Now, XR4 for 50 years, for instance, means that you have 4 times square root of 50, means 28 millimeters of carbonated concrete in the period of 50 years with a probability of 90%. Okay, this is more or less a rule of the thumb. This should read, if you use the proper probabilistic approach, you should read 3.6 times square root of 50, but it established the idea. So the XRC class number represents a dimension of carbonation rate. The minimum concrete cover is then semi-endur for the XC exposure classes, and the XRC until XRC7 exposure resistance classes are then given in a table. First thing that we see is that in the version of 2004, we had structural classes going from S1 to S6, and in the later versions S5, but you had different structural classes and different types of semi-endur. Now, I was wondering, where is the structural class now? Well, they have put it here. You only have 50 years and 100 years design reference life. All the others, there is no number given for that. Second, if we look at the XRC classes and their number, and we use the formula that we had used just now, and the square root of 50 times the number, then you receive, this is the millimeters of carbonation. And then you see it's more or less in correspondence with the XC4 ratio, 50 years, but the figures are rounded off and things like that. It's just a matter of ease of use. When we take, for instance, for a reference for a design service life is 100 years, then you got the number times square root of 100. So then you will see that this corresponds rather well, but sometimes there are deviations because the whole system is based on a lot of tests. And for instance, to give you an idea, for an EC2 class, you have 4 models of carbonation rate, the depth. And then if you have on the x-axis our carbonation rate and the y-axis, you have the carbonation depth. Then for the 4 models, you have different lines. So there are a lot of studies, and it all depends on the probabilistic assumptions that you made before you arrive at this figure. So those figures are based on all those graphs, on probabilistic assumptions, and then they round it off or they limit it to a certain minimum value. For instance, you will not have a concrete cover of 5 millimeters, which makes no sense. Depth of chlorides penetration, characteristic value 90% fractile, corresponding to a reference chloride concentration of 0.6% by mass of binder cement, assumed to be obtained after 50 years on a concrete exposed to one-sided penetration of a reference seawater mix of 30 gram per liter natrium chloride at 20 degrees Celsius. So this is really a standard. And then you can have also the exposure resistance classes for chlorides, XRDS, and it has a dimension of a diffusion coefficient 10 to the power minus 30 meters squared per second. For instance, XRDS4 means then the depth of penetration is 25 times the square root out of that number, and it's 50 millimeters in this case. Why 25? Well, it has to do with units and with the probabilistic approach. So this means after 50 years under the set conditions, those conditions, the expected penetration depth of the chlorides is 50 millimeters. Okay. Then you can have a table also for semi-endur in function of XS1 to XS3 and XD1 to XD3. So you make combinations of it. And then you have the different exposure resistance classes and the minimum required concrete cover. Now, the first thing in Eurocode 2 version 2004, the maximum minimum cover of reinforcement was 55 millimeters for structural class 6 or 5, that's for bridges, and that was 55. Now you will see immediately that for XS3, that's for marine structures, that you can go up to 80 millimeters already. Even in XS2, you can have 80 millimeters. So that's significant more. And you can ask the question, is this feasible, making a concrete cover of 8 centimeters? Don't you need skin reinforcement now? Don't you have to fear falling of the concrete? So the same happens with XD1 to XD3. So the needed concrete cover is much higher. Then the nominal cover is then the minimum cover plus the tolerance. The minimum cover is then the maximum of what is stated here. And the delta C is a summation of different delta C's. And delta C min 30 means that when you have a design service life of less than 30 years, you can subtract 5 millimeters. You see, the structural classes were omitted in the table, but they will come back in the formulas. Same in execution. This is the enhanced compaction of concrete. It means, in fact, structures with slab geometry and occurring class 3. So this also, you can subtract 5 millimeters. This is also due to the fact that they do not use structural classes, so they cannot diminish the structural class for certain conditions, so they have put it into a formula. Same in P is the pre-stressing tendons, then you can add 10 millimeters if you use pre-stressing tendons pre or post-tensioned. Then you have an additional reduction for protection of concrete, additional protection of concrete when you have surface coating, then you can subtract 10 millimeters. Additional measures other than coating, none. You cannot have any gain on that. Concrete abrasion. So for XM1, M2, and M3, you can subtract 5. You can add 5, 10, or 15 millimeters. And same in that are the tables that we have seen, 6.3 and 6.4. It's annoying that there's no table for XRF. So I don't know what to do with XRF when you only have XRF. So maybe the tables will come, but at the present version of Eurocode 2, it is not present tables for XRF. Same in B is the maximum diameter used for separate bars, and it's the maximum diameter plus 5 millimeters for separated bars with a diameter bigger than 32 millimeters. And same in B is equals to this formula for bundled bars. Then the allowance for the deviation delta C def, you have now instead of just only 0, 5, or 10 millimeters, they have now made a table with explicit conditions so that it is that you so that it's clear what to use. In general, it will always be 10 millimeters, and if you have an execution intolerance class 2, you can have 5 millimeters, and so on. I will not read all those different elements, but we can recognize the 40 millimeters and the 75 with this traditional. Due to the philosophy of exposure resistance class, comparison with the present method of calculating the concrete cover is in fact not possible. So you remember the exposure resistance class uses the defining performance of concrete, and the present method of Eurocode 2 version 2004 is based on defining the content of mixture. Because of those two completely different principles, it is impossible to compare on an equal basis the required minimum cover of concrete.